Okay. So we have finished the circle. Okay. So now we'll start with parabola. Okay. So we are done with circle. We'll start with parabola now. So four conic sections we have discussed. One is circle, one is parabola, one is ellipse, and one is hyperbola. So we have covered circle. Now we'll start with parabola. Okay. Where is my spec? So So parabola is the set of all points in a plane that are equidistant from a fixed line and a fixed point. Okay. So so this it's the line passing through all the points. These points are equidistant from a fixed. These points are equidistant from a fixed line and a fixed point. Okay. So let us see what does it mean. Okay. So let's say this is my axis. Okay. So let's say this is my axis. Okay. So let me draw a line, a parabolic line. Okay. So let me draw a line. Okay. This is not so. So let me draw a line like this. Okay. So and let me say uh, I have a line like this. Okay. So let me say I start with a point like this. Okay. Let us say this point. Okay. Okay. So now I am telling it is a line passing through points. Okay. So let me say I have a point, this point, and I have this point, and I have, let us say, this point. Okay. So this point is called the focal point. Okay. So I am measuring distance from this focal point. Let us say this is my point P1. Let us say this is my point P2. Let us say this is my point P3. Okay. So these are my 3 points. So the distance from this point and the distance from this line are equal. Okay. So this is, so this is equal to this. Okay. Similarly, let us say my other point is, let us say, somewhere here. Okay. So let me say this distance. Okay. So this is my distance, and we say this is a distance from the focal point. Okay. Similarly, this is the hard. So this is my third point. So now this is equal to this. This is equal to this. Equal. Yeah. So let us say this point is F. Okay. And let us say this is my B1, this point is B1, this point is B2, this point is B3. Okay. So you can see in the other room, my spec will be there near that. Okay. this is the condition. Okay, so P1 B1, P2 B2. So P1 B1 is equal to P1F, P2 B2 is equal to P2F, P3 B3 is equal to P3F. So this condition it has to meet this condition. Okay. So there are two things here. One is line and another is point. So you are measuring the distance of point on the parabola from a point and from a line. Okay. So when you are measuring the distance from a line, it's kind of joining from the perpendicular distance that you are measuring from the line. It's easy to measure from point to point. Similarly, from line means a line, vertical line, a perpendicular distance you are measuring. Okay. Otherwise, measuring distance from a line, what does it mean? That is the smallest distance. Let us say I have a line and I have a point. So suppose somebody is asking, you are measuring distance from the line. You are measuring distance of this point from this line. So there can be many things. It can be this, it can be this, it can be different things. But you have to consider the lowest distance, which is the perpendicular distance. Okay, so the distance from a line means the minimum distance, or which is the perpendicular distance. Okay, so that in this case that's what it means. So we have two things in parabola. One is this line, another is this point. So this point F is nothing but your focus or focal point.
Yes.
Okay, so this is important in case of a parabola. That is called the fixed point. It is otherwise called as the focus. Okay. Okay. What does the literal meaning of parabola? Okay. So para means for. Okay. Para means for. Okay. Bola means throw. Okay. Bola means throwing. Okay. Throwing. So when you have studied in your kinematics, okay, that when you are a projectile, when you throw something, so let us say, how does a projectile motion looks like? So suppose you are just throwing something, that means the gravity is acting on it. So it will follow a projectile path and fall down, right? So so this is, so I am throwing something. It will go to reach the maximum height, then it will fall down. Okay. So there are formula for maximum height that it can reach, that is the H max. Similarly, there are formula for the maximum range or the distance. So those things are there. So you can remember those formula and it will be useful in your physics. Okay. So those formula you have to remember. Okay. So that's what. So from this. Because when you are throwing a ball, so this is parabola means, bola means throwing, para means for. Like when you are throwing something, the kind of path it is following is a parabola. That's why it is called parabola. Okay. So the shape described when you throw a ball in air. Okay. So okay. A line through the focus and perpendicular to the direction is called the axis of parabola. Okay, and then there is a point and there is a this fixed line and a fixed point. This fixed line is called directrix. Okay, so this line is called directrix. There are two things. One is focus, one is directrix. Okay, so a line through the focus and perpendicular to directrix is called axis of parabola. So this is your axis. So it is perpendicular to the directrix and through the focus. So this is your axis of parabola. Okay. This is your axis of parabola. Axis of parabola. Okay.
Yes.
So follow it seriously. Don't think that this is not there in CET or whatever. If it is not there in CET, it may be there in Comet K, because in other states it might be there. Okay, does not matter whether it is there in Karnataka PUC or whatever, or main J it will be definitely there. So do whatever is the simpler ones, not that this is not there, that is not there. Okay, so the line passing through the focus and perpendicular to the directrix is called axis of parabola. Okay. So the point of intersection of parabola with the axis is called vortex of parabola. Okay. So wherever the point of intersection of parabola with the axis, so this is my axis and this is my parabola, right? This is my parabola and this is my axis. So wherever this parabola intersect the axis, that is called
Vertex.
vortex. Okay. It's called vortex. This is vortex. So many things. Vortex. This is focus. Okay. Then this is directrix, and that is parabola. So these four things you have to remember. Okay. Yeah, so here in this book it is clearly given. So if this is my axis, this is my parabola, so this is my directrix, this is my vortex, this is my focus, and this is my parabola.
Yeah.
Okay, so these are the things you should remember. Then, after having this understanding, we can develop the standard equations of parabola. Okay, you can take a picture, then we will derive the standard equations of parabola. Can you switch on the fan? It is very hot. That one, just turn it. So now you have understanding. Okay, the points on a parabola will be equidistant from a fixed line and from a fixed point. Okay, if it meets that condition, then it will be parabola. Okay, then standard equations of parabola. Okay. Standard equations of parabola. What are the standard equations? Okay. The equation of a parabola is simplest if its vertex is at origin and the axis of symmetry is along x-axis or y-axis. So the four possible such orientation of parabola are shown in figure. So if your vertex is at origin, okay, so the generalized condition is like this is my directrix and this is like this. This is my focus, this is my vertex, okay, vortex. So this is the generalized one. But the simplest one will be if like this is my origin, 0, 0, right? This is my origin, this is my axis of the directrix. Okay, so a more simplified one can be, like if my vertex is at origin, so in this case, so if it is through the origin, so this is here, it is at origin. So in this case, its directrix will be somewhere here. So this y-axis has equation x is equal to 0 because in y-axis x coordinate is always 0. So here this directrix will have equation x is equal to minus a. Okay, so this is yeah. And this is one condition, or it can be something like this. Okay, so it can be with same origin. So sorry, it can be something like this. Okay, if your parabola can be, but it is symmetric about your x-axis. Okay, so this is your x-axis, and let us say this is your y-axis. Okay. So this is so your in this case your directrix will be x is equal to plus a, right?
Yes.
So this is one case where your parabola is symmetric about x-axis. So so this one, when it is towards the positive axis, your equation will be y square is equal to 4x. Okay, y square is equal to 4ax. This one will be y square is equal to minus 4ax. So that's the equation for that. Okay. So y y square is equal to 4x. Yeah, y square is equal to 4x, and this is y square is equal to minus 4x. Why is it so? Because here x is always positive.
Yeah.
So x, that means x is equal to y square by 4x. So whatever it may be your y coordinate, x will always be positive. That means here you can see x is always positive. That means it is only one side. And here you can say x is always negative. Y square by minus 4. That's why this is y square is equal to 4x, and other one is y square is equal to minus 4x. So these are two types. Okay, so two types. So this is symmetric about x-axis.
Then y-axis also.
Then there are some condition where we will have symmetric about y-axis. So we will have so this, and you have this. So this is this thing. So here you can see that x square is equal to 4ay.
4ay.
X square is equal to 4ay.
X square is equal to minus
4ay. X square is equal to minus 4ay.
Here it is positive, there it is negative.
Yeah. So this is the equation. So here in this case, always your vortex is at 0, 0. Your vortex is at 0, 0.
Yes.
Here also your vortex is at 0, 0. Vortex is at 0. And if this is the vortex, similarly your directrix will be little below this.
Yeah.
And here also your directrix will be below.
Yeah.
Okay, so in here the equation was x is equal to minus a, here y is equal to, so the equation is y is equal to minus a, so if it is down, y is equal to minus a. So x axis has that, means y is constant. Okay, so here y coordinate is constant, so y is equal to minus a. Okay, and here y is equal to plus a. So this line is y is equal to plus a. So your x-axis is nothing but y is equal to 0. Yeah. Y is equal to 0 is nothing but x-axis. So it is y is equal to minus a if it is above, below, y is equal to plus a if it is above. Okay. So these are some of the different cases. Okay. So you can take a picture of this, then we will go to the generalized condition. Okay. So these are the 4 different conditions. So yeah, x square is equal to 4ay, x square is equal to minus 4ay. Okay, so now we'll derive the generalized equation of your parabola. So we know my generalized thing is, say, okay, so this is my axis. Okay. So this is my another axis. Okay. So this. So let us say, sorry, actually it is little bit away from the axis. Okay, generalized case.
It is not typology.
So it is a generalized case. So vortex is not at 0, 0. Vortex is at some other point.
A comma B.
So your vortex is at some other point. So here, let us say there is a point. Okay, so this is a point. So I can join this point with this and this point with this, right?
Yeah.
So let us say any point on the parabola will be point P with coordinate x and y.
Yeah.
Okay. And then let us say this is my focal point whose coordinate is equal to A0, because it is on x-axis, so y coordinate is 0.
Yeah.
And let us say from the origin it is at a distance A. Okay. And let us say my directrix is somewhere here. Let us say little behind the y-axis.
Yeah.
Let us say my directrix is somewhere here, so I will measure my distance from here. Okay. So it is a you just see, it looks very big and this looks small. You don't get confused.
Yeah.
It is just a representation.
Yeah.
Don't get confused about it. Okay. So this is point P, and let us say this is my point B. Okay. Let us say this is my point B.
B.
And the equation of this line is nothing but x is equal to minus a. See, this is x is equal to 0. Your y-axis is nothing but x is equal to 0. So this is x is equal to minus a. So now this as per the equation of parabola, this PB will be equal to PA. If this is the case, then it will be a parabola. Okay. So how much is my PF? Okay. So my PF is nothing but, so if you draw a perpendicular from here, okay. So your PF, let us say it will be, PF is this. So this is nothing but this square plus this square.
Yeah. Pythagoras
So,
theorem.
let us say this is what do we say? We call it as base, right?
That is base, this is perpendicular, and that is hypotenuse.
Capital I am writing. So PF is nothing but your hypotenuse. Okay, so this is P square plus B square, right? Square root.
Yeah.
Right? How much is your B here now? So this is your B, right?
Yeah, base.
So your B is nothing but we have to find out what is the magnitude of B. EF is equal to x minus a whole square y square. Okay. So you know this you can see here minus my P is nothing but my y coordinate.
Yeah, yeah.
So my perpendicular
That
is
is
nothing
y.
but my y coordinate, right? So P is my y coordinate.
B
How
is
much?
x coordinate. No, B we have to find.
B I have to find out. So B is your x minus a. So what
Yeah,
is
x
your
minus a.
So what is your x coordinate? So your x coordinate is from here to here.
From origin to
Ah.
that point. And then the A coordinate is that much.
Which one?
B will be x minus A.
B will be x minus a. So
A is from there, from vertex to F point. Yeah.
so from origin to this is nothing but my x.
Yeah.
Okay. So and then from if it is little behind this
From origin to F point is A coordinate. So B will be x minus A. That is A comma 0. We are measuring it from origin.
okay, so this is my a comma 0, right?
Yeah. F
This
point is A comma 0.
Okay.
That A is measured from the origin.
Origin, okay.
So then the base length, magnitude of base will be the whole thing A minus x.
X. Correct.
Yeah.
So you don't confuse with this. So
We are not supposed to measure from directrix.
Yeah, that's fine. So don't confuse with the directrix. So now you know my focal point is at a distance a, and this is x, so this becomes a minus x.
Yeah.
So you know this is
A. That is A. So
and
base
that is
will
x.
be A minus x.
X. Okay. So my PF becomes y square plus a minus x
Whole square.
square.
Yeah.
So this is my PF.
Then your square on
Hmm.
PF value is y.
Yeah. So
Substitute PF as y.
yeah. So now first I have to find next I have to find my PB. Right? My PF is equal to PB, na?
Yeah.
Derive the equation.
Yeah.
So my PB is what is my distance PB. So I know this point is at a distance x, right?
Yeah.
This is x and this is also x, right?
Yeah.
So this distance is x and this distance is a, I know, right?
Yeah.
This distance is at a distance a.
A.
So PB is equal to x plus a.
A. You have to equate both.
So PF is equal to PB. So that implies x plus a is equal to PB is equal to PF. Okay, so x plus a is equal to y square plus a minus x whole square square root.
Yeah.
Okay. So okay, so this a minus x also can be written as x minus a. Okay,
Yeah.
a minus x square, you square does
It
not
doesn't
matter.
matter.
X minus a whole square plus y square square root is equal to x plus a. Okay. So this become x minus, you have to square both sides. So
Yeah.
x
Plus
minus
y
a whole
square is
plus
equal
y
to
square
x plus a whole square.
x plus a. So this.
Then you open it, x square and a square will get cancelled.
So finally you will end up with the equation called
Y square is equal to 4ax. Is
So
generalized
that is the generalized
equation of parabola.
So you now you know how it is being derived. So y square is equal to 4ax
Yes.
is the generalized equation.
Of parabola.
Yeah. So what is a? A is the distance of the focal point from the origin, not from the directrix.
No,
from the
you are
origin.
not supposed to mention
Yes.
directrix.
So y square is equal to 4x is the generalized equation for a parabola. Okay. So what are the different observation? Okay. So this is one case. So the other form of parabolic equation can be like y square is equal to 4ax is one case. So
This
you
is
can have
because
y.
parabola in first quadrant.
It is in the other quadrant it is minus 4x.
Depends on which quadrant
Ah.
it is.
So it is x square. So if it is y square, that means it is symmetric about x axis.
X-axis.
If it is y square, it is symmetric about x axis. If it is x square, it will be symmetric about y axis. And if this is plus, that means it is in the first quadrant.
First and fourth, here it is second and
So x square is equal to 4ay and
x square is
x
equal to
square is
minus
equal to
4,
minus 4ay.
4ay.
So this, as I had explained earlier, so it can be like this, okay? It can be like this, okay? Like this. It can be like this, okay? So it can be like this or it can be like this.
Yes.
So these are different cases. So case 1, case 2, case 3 and case 4. Okay? So these are the simplified equation. Y square is equal to 4x. So what are the general observation? Okay, parabola is symmetric with respect to axis of the parabola. Okay, if the equation has a y square term, then the axis of symmetry is x.
Yes.
If it has a y square term, axis of symmetry is x, and if it is x square term, axis of symmetry is y. Just there can be simple multiple choice questions like this. Okay, when the axis of symmetry is along x axis, parabola opens to the right if the coefficient of x is positive. So this one. So this is if the coefficient is positive. So this is if this term is positive. 4a is positive, so it will open to the right.
Yeah.
If it is negative, it will open to the left. And same is the case. Here it is positive. This means it will open to the up side. And if it is minus, it will open to the down side. So those are. And the second observation, when the axis of symmetry is along x axis, therefore open right is the okay that one. Okay, that one is the observation. Okay. And directrix. And then you can take a picture, then we will discuss what is latus rectum. Okay, you take a picture of this, then we will discuss what is latus rectum. So now you understand? So latus rectum of a parabola is a line perpendicular to the axis of the parabola through the focus and whose end point lie in the parabola. So this is my parabola. Let us say like this. Okay. And so this is my focus. Okay. So the latus rectum, it is perpendicular to the axis of parabola. So this is my axis of the parabola. So that latus rectum is perpendicular to the axis of parabola and it passes through the focal point. Okay. So this passes through the focal point. Then this is called latus rectum.
Which is 4a. The magnitude.
So this is my latus rectum. So the by definition of parabola, so how you find the length of latus rectum? So let us say they are saying Okay. So my coordinate here is A0. This is A0, and let us say it is from the generalized, from this line. So let us say this is this. So let us say this point is A. Let us say this point is B, and let us say this point is C. Okay. So this is x-axis, this is y, y. Okay.
Y dash x.
So this. Then we know AC is equal to FM. Okay. So see, this is also a point on the parabola. So what will happen? My AC, as per the definition of parabola, AC will become equal to FM, right?
Yeah.
So AC is equal to FM, and AF is equal to 2A. AC.
Yeah, because it is A plus A.
So this distance is A.
That is also A, so it is 2.
So this is also A, because this is nothing but your x equal to minus A. This is A. Okay, so if A, then your AC is equal to 2A. Right? AC is equal to 2A.
Yeah.
So AC is equal to FM is equal to 2A. Okay. Hence, F is equal to 2A. Okay. AC is equal to 2A. FM is equal to 2A. Okay. Then, okay. Okay. Then AF is also equal to 2A, because that is another point, right? So AF is also equal to 2A, because that is another point. Some from AF is also equal to 2A. So since the parabola is symmetric with respect to x-axis, AF is equal to AB. So AB is equal to length of the latus rectum. So what is the length of the latus rectum? So AB is length of latus rectum. Latus rectum is equal to 4A.
Yeah.
Okay, so that is the formula for length of latus rectum. So that is just to be remembered, and you can solve some examples. So there are some solved examples on parabola. You can solve all of them.
Okay,
And
I'll do it.
so you can solve all these. Okay?
I'll do it.
Okay, so then quickly I'll I'll go through ellipse and hyperbola in 10 minutes. Okay, you can, those are, because you don't have much time, we'll just cover it quickly. Okay, so this is parabola. You can solve numericals on this.
Yeah.
So you now know what is directrix, what is focal point. Now you got to know what is your latus rectum, what is the length of latus rectum.
Yeah.
And how there are 4 types of equation: y square is equal to 4x, y square is equal to minus 4x, x square is equal to 4ay, x square is equal to minus 4ay. So when it opens to the right, when it opens to the left, when it opens to the up, when it opens to the down. So all that different cases I have explained. Okay. And now we have explained, you can take a picture. Now we have explained what is latus rectum, and we proved that the length of latus rectum is around 4a. Okay.